Good morning all. So today we will discuss about big data technologies and databases of Hadoop. So actually coming to the point of data. Data is nothing but a character or a symbol you can take or any quantity where we are making operations by a computer so that we can get a signal out of it or that can be transmitted as a signal and it is stored on a magnetic or any optical or any mechanical medium. So data is all about that. And coming to the point of big data. Big data is high volume, velocity and variety asset where we are exactly applying the concept of transformation. Quality information must be taken for the good decision making. Insights must be taken for good decision making. So coming to the next part of this, Hadoop, where requirements of Hadoop framework, design principles of Hadoop, comparison with other systems like SQL and RDBMS. Hadoop components will discuss architecture and Hadoop 1 versus Hadoop. And initially, what is the foundation for the Hadoop? This is an open source project of Apache Foundation and it is a framework written in Java, originally developed by Doug Cutting in 2005. And this is mainly taking a foundation of Google file system technologies and MapReduce. And then Hadoop is now a core part of computing infrastructure of the companies like famous companies like Yahoo, Facebook and LinkedIn and Twitter, etc. So this is clearly showing what is the Hadoop framework is all about. So Hadoop, here we are having Apache open source software framework. We can define Hadoop in this way and inspired by, this is the foundation for this Hadoop architecture is MapReduce and file system. Google's MapReduce and Google's file system. And here we are having the core components of Hadoop. Hadoop distributed file system and MapReduce. So key advantages offered by Hadoop for big data analytics. The first one, stores data in its native format. So meaning we are getting so many sources for data. We are taking data from so many sources. So that maybe stores data in its native format. That means structured data we can take, unstructured and semi-structured data will be there. So whatever it may be, we will consider that data whenever we are writing into the Hadoop infrastructure. So that is taking without any issue of formatting. So no loss of information as there is no translation information to any specific schema. So we are directly taking and storing on the infrastructure. So no need of translation, no need of data loss. Scalability, proven to scale by companies like Facebook and Yahoo. Scalability is a horizontally scalable because we are going to have so many servers, commodity servers. So with the help of commodity servers, we can horizontally get instead of increasing the capacity, configuring it and using the highly configured systems, we are increasing the number of servers. Delivers new insights. So with the help of quality information that we are taking from the so many resources, we can have a clear insight of that data. So transformations and analytics make sense in this particular point. Higher availability, fault tolerance to replications of data, failover across computer nodes. So whenever we have a single copy of the data, there will be chances of getting failed on that particular node. So instead of making one single copy, we can have multiple copies on different nodes so that we can avoid the problem of fault in particular node. It won't interfere the entire process. So reduced cost, lower cost and terabytes of storage and processing. So with the help of data processing schema, so we are using the commodities of hardware and that with the help of that we can tell it is taking lower cost compared to other traditional systems. Hardware can be added or swapped in or out of the cluster. Hadoop can be stored and distributed very large data, horizontally scalable. We can add number of servers into that. And this is cost effective because it is having a scale out architecture. So that means we will add the servers instead of taking the high-end servers. And resilient to failure. So we will have replications of the data so that one node data gets failed, we will work with the other node. So flexibility, one of the key advantages is that we will take all the different varieties of data from that, but we are just taking the quality information out of it, insights out of it for the good decision making. And the processing is extremely fast in Hadoop as compared to other conventional system because the move in and move out is very easy. We are not having any transformation as such. Hadoop has the shared nothing architecture because it is having its own. The nodes are having its own hardware like CPU, memory, storage system and all. This is individual. It is not sharing that constraint. So these are the some differences between SQL and NoSQL. Coming to the key areas, and with the SQL and NoSQL, how it varies, you will see. Type of data that we have it as in SQL is a relational database, in NoSQL non-relational database. That means we are having not only relational, but we will take some other language for taking the structured, unstructured and semi-structured data. And schema, what schema we are going to use in SQL? Predefined schema you must use. In the NoSQL, dynamic schema we must use. So dynamic schema is nothing but whenever we have such demand, so we will be turning into that format. Otherwise not required. So we will directly connecting to the databases and showing on the data. Database categories. So what we are going to have table-based databases in SQL, and in the NoSQL we will have a document and key value pairs are there, graph streams are there. So these are the main types in the categories of NoSQL. Complex queries that will be processed. This is good in SQL only. So that is what is not handled properly in NoSQL. And hierarchical data storage, not the best fit in this one, but NoSQL will take that hierarchical queries easily. And scalability, here vertical scalability, we are increasing the capacity of the one server in a particular context. Here in the horizontal scalability, we are including the number of servers. As per our request, we are including the servers. And the language, structured query language, here unstructured query language we will use. Online processing, this is used mainly for online transaction processing. This is for the analytical processing. This is best used for the analytical processing. And base properties based on the ACID properties. We all know, we are aware of the DBMS concept. So this is to the, it is particularly based on the ACID properties, and this is cap theorem. So maybe this cap theorem, only few will get satisfied completely in the concept of NoSQL because it is taking all the data, structured data, unstructured data, everything it is processing. So one of this should be compromised, like cap theorem. C is for consistency, A is for availability, and P is for partition tolerance. So here excellent support from the vendors. Here rely on community support. So these are the other differences we have. So SQL, NoSQL relational database we will consider, and non-relational. Maybe some things gets repeated, but it is very essential. Relational model, and here model-less approach because it is taking the variety of data. So we will fix after write operation. Predefined schema here in the SQL And now the additional one gets added here as NoSQL. So what are the problems with SQL, NoSQL? So that is what they are trying to rectify. It is as a goal now. So others to asset properties, yeah, yes, SQL is yes, and NoSQL no. It is not othering the properties of ACID, and NoSQL yes. So we are trying to achieve the consistency out of these two. Now in the context we have got NoSQL. OLTP, OLAP, yes, this is also completely taking care of transaction processing and analytic. But here OLTP is somewhat compromised again. Here yes, which is somewhat close to SQL. The NoSQL is somewhat close to SQL. Schema rigidity, yes, rigidity, that means it is schema oriented. And this one, no, maybe. So we will have adherence to the data model, yes, this is completely adherence to the data model, and these two, no, because it is accepting data from so many data sources. Data format flexibility, this is not having data format flexibility, this adheres to the particular format. So structured one only. Here, yes, the flexibility is there. This is maybe. So because it is giving you the ACID properties, it's somewhat clearly saying about the consistency issue. So format flexibility may not be there, maybe or may not. Scalability, scale up vertically. I told about the system's capacity gets increased. Instead of increasing the system's servers, it is increasing the single server capacity. So vertically scalable. Horizontally scalable means you are taking the servers, number of servers for our application. If the data gets increased, we are adding the servers instead of increasing the capacity of the server which is already exists. This is the scale-up architecture, same, it is maintained the same as NoSQL. And distributed computing. Yes, distributed computing is there for all the three. And next one, community support is huge because it's vendor specific, it is huge. Now it is growing and this is slowly growing. Because it's a new version, this is as a goal now. Now, Hadoop versus Hadoop. This is also similar to the concept of SQL and NoSQL, but we are discussing in terms of the infrastructure, Hadoop and RDBMS. So it can process kind of data such as structured, semi-structured that we had already. So this is clearly telling you about the NoSQL architecture. So here coming to this point, SQL architecture clearly says that mostly structured data processed by RDBMS. And coming to this point, processing coupled with the data storage. In the Hadoop, processing coupled with the data storage. But in this case, mainly for the storage. This particular thing is for storage. And processing is limited and somewhere it is no more. Processing is somewhere no more. So here, in the context of Hadoop, schema is required on read. So whenever we read out of that HDFS, we need schema. When we write, schema is not. But in this particular RDBMS, schema is required on write. And anyway, when we are maintaining the schema when we are writing, so no need of the quick processing is there for the read operation. So write performance is faster than read because it is accepting as it is whatever data comes to that DB store and it will be storing on that. After that, it is converting to the required format. But in the RDBMS, it takes more time. Write operation takes more time. Read operation is less time. Because it is converting, then it is reading. So that's why the reads are faster than write. Software license is not required, that is open source. License is required for this RDBMS. And coming to best fit for process big data, unstructured data, and massive data. So this is best fit for OLTP, online transaction processing. So it is in detail we can have again. So data variety, what type of data is taken in the Hadoop? That we all know variety of data. It may be a structured data, unstructured data, and semi-structured data. So we can use different types of data Data storage is usually in the size of terabytes or petabytes, so that RDBMS is in gigabytes. So query responses are very high. It is taking high fuel for that one. Here we are having SQL. So querying and query responses is nothing but whatever data comes to us, that gets transferred first. Okay. So wherever we store data, after that it should be transferred to a particular application base. So for that we require high fuel. And schema is required on read, schema is required on write. So whenever we read out of the storage, that time we require read. So whenever we write, that time we require anyway we converted into the required format. So reading gets easy for us. That is the RDBMS concept. So speed writes faster compared to the read. That is already previous slide is all about. Reads are very fast, building indexes on the required columns. And here fast is Apache is an open source large scale distributed scalable data intensive computing. But in the case of RDBMS, it is vendor specific. You have to pay for that. And use cases of this one, analytics, data discovery, and OLTP is the best use case for the RDBMS. Yeah. Here coming to the throughput. Throughput is high in the Hadoop infrastructure, where in the case of RDBMS, throughput is very low. So scalability horizontally scalable. I told you increasing the capacity of the system. Hardware, commodity hardware we use. Integrity is low in the case of Hadoop. Where in the case of RDBMS, integrity is more by following these ASIC properties. So this is a Hadoop environment. First component is that MapReduce, and second one is HDFS, Hadoop Distributed File System, Yarn framework, and common other utilities supported for this framework. So this MapReduce is used for the transformation, processing of the data. Where in the case of HDFS, this is used for distributing and storage of data. Yarn framework is used for the managing and controlling of the resources. Other commodity utilities also, based on the application demand, we will use all that. Here Hadoop components, first section is about the Flume, Uzi, Mahau, Hive and Peak. These are all the extra layers we will take in the Hadoop architecture. These are all having its own specialty. Flume is like managing the resources. Uzi is also managing the resources and schedulers. Mahau is for the machine learning algorithms along with the Hadoop architecture. Hive and Peak, this is for the transformation from the input source, that is whenever we are writing and reading, that time we will use all this. The transformation schemas and configuring and scheduling, coordinating the clusters, all this we will use that time. And the core components are MapReduce programming, Hadoop distributed file system. Ecosystem is a powerful tool for big data. Hadoop ecosystem revolves around three main components. One is MapReduce, another one is HDFS, another one is the Yarn. So clearly it says about MapReduce is the cluster management. So processing is done with the help of MapReduce. HDFS, this is for the storage, and this is for Yarn is for the resource management, clustering and resource management. This HBase is also similar to the MapReduce HDFS, but it is column structured format is required. So these are all, as I said, Uzi workflow monitoring, Chukwa monitoring, Flume also monitoring. All these jobs gets monitored. Zookeeper, this is also centralized monitor. So these are all the sections explained like this: data management, data access, and these are all Hive, Pig, Mahau, Agro. These are all architecture. These are all data processing. This MapReduce and Yarn gets used for data processing, and the last section is for storage. So data storage layers we have here. HDFS we all know, Hadoop distributor file system, and components of that, name node and data. So name node is having a metadata about your client and application. You have a metadata. Data node is having the actual data. So that client is interested. And HBase is also similar to the